Okay, so the, just to illustrate another mixture problem, let's say you have a tank full of 10% solution. And 4% solution flows in at 10 gallons per minute. And let's say it's a 1,000-gallon tank. Okay? So, dq dt, 4% of your 10 gallons, right? So it's going to be that's what's coming in. And then you're going to have gallons per minute. And that equals 0.4 gallons per minute minus 1/100th cube. And it's just going to be per minute. Okay, because you got actually gallons there. Right. Okay. And I'll just suppress the units since they work out. Can we get this? Okay. So that dq divided by this equals dt. Equation's also linear, but it doesn't always turn out to be linear, so you really want to do it as a separable equation, and you end up with this integral. You're going to do the u substitution. So you find that if u equals its denominator, dq is negative 100 du. So you have this equals the integral of dt, so negative 100, natural log of the absolute value of u equals t plus a constant, leading you to u equals a e to the negative t over 100, just simple exponential function. Okay? And steps in here we've been over a number of times. Pretty standard. And of course you gotta know how to do those steps. Okay, so there's our function. Of course, okay, that's u. And u is 0.4 minus q over 100. Okay, so q equals still a e to the negative t over 100, where a is anything except 0. And it's going to be then plus 40. Okay, and what's this difference of 40?
No.
40 is going to be the amount of solute you have as t approaches infinity. So because clearly this decreasing exponential is going to approach 0. So q is going to approach 40. What's that mean? It means $40 gallons of solute in the 1,000-gallon tank. Okay, well, common sense. You're going to end up with a 4%, so you're going to approach a 4% solution, because that's what's coming in, and the mixer's going out. So the mixer starts out at 10%, but it's clearly going to approach 4%. Okay? So this solution makes sense, and you want to make sense of the solution. And if you got something like this, you look at the limiting value of the quantity of solute. And it's implicit, you know, we've already talked about Q's and minus solute and so forth, so I've skipped over explaining that and just run through the arithmetic. Well, that's how it goes. Okay? Now, if I want to know when does a solution reach 6%? Okay? Well, how would you solve that?
Set Q equal to 60.
Yeah. Okay. And then just a matter of doing a simple arithmetic, but we'll do that just to illustrate it. Okay? So, 6% concentration Q equals 60, so solve 60. Of course, we haven't evaluated A. I'm apparently not totally with it today. I'm going to do that. And I got, never mind. Okay, so how are you going to evaluate A?
So initial conditions.
Yeah.
T.
And so I'll just make a quick note here that initially you got 10%. So A has to be 60, right? because e to the 0 is 1, 60 and 40 makes 100. Okay, hopefully that's clear. Okay, so it's 6% solution, you've got this, and A is 60. So what's this become? So 60. Now, I'm skipping a step, but just subtract the 40. You get 20 equals 60 e to the negative t over 100. So e to the negative t over 100 equals 1/3. Divide both sides by 60. So the natural log of e to the negative t over 100 is a natural log of 1/3. So negative t over 100 equals a natural log of 1/3. T equals negative 100 times the natural log of 1/3. Okay? And the natural log of 1/3 isn't too far from negative 1. Okay? It's like negative probably 1.1 to 1.2. So I'm going to say that's maybe 110. Takes 110 minutes to get down to 6% solution. So you can pretty much answer any question about when Q takes a certain value, or when is Q changing at a certain rate. Okay? Take the derivative of this, you get the rate of change of Q, set that equal to a rate. Okay? So if you use common sense, of course common sense is something that we develop by doing a lot of problems. Okay? I'm not born with it. You got to have experience. Okay, so that's the situation with the first problem. Now the other problems have slightly more complicated conditions that give you slightly more complicated solutions. If you understand this, you can adapt. Okay.